Okay, hello. This lesson is on parent functions. So our essential question is, what are parent functions? Before we get into that, I want to talk a little bit about interval notation and how they relate to inequalities. So you're probably familiar with something like this inequality right here. If we read this is x is less than or equal to 5, which means if I were to graph this on a number line, let's say this is 0, here's 5, less than or equal to, here's 5 is included, so at 5, I'm gonna put a closed dot, and then maybe I'll just use this highlighter. And then we're gonna shade everything to the left, so that would be everything this way, and it goes all the way off to negative infinity. Okay, so interval notation is another way to write an inequality, and it's just saying under what interval are the numbers that you're talking about, or what numbers are included from what to what. So the way that we do this is we write it with a parenthesis or maybe a bracket, one or the other, okay? So you could have brackets facing this way or this way, parentheses this way. You use parentheses if the number is not included, and you use brackets if they are included. So in this particular case, 5, this number 5 here is part of the solution set, so we would use a bracket next to 5. Now we always start with the number that's the furthest to the left, all the way to the left. So the smallest number, in other words. In our case, this line goes all the way to negative infinity. Okay? And then we put a comma. So you're going to start at negative infinity, which is kind of weird. You'll notice I used a parenthesis because you can't really stop at negative infinity. It just keeps going forever. So that's why we put up parentheses whenever you use infinities, negative or positive. And then this goes all the way from negative infinity to the left, all the way up to here till you stop right here at 5. Now 5 is part of the solution set, so you're going to put a bracket. So what this means is all numbers from negative infinity all the way up to 5 are included. That's the interval. So that's how we write interval notation. Okay, so then here are some other examples. Let me just show you some other things. Hopefully this will make a little bit of sense. I'll explain this a little bit further here. Okay, so this one right here is x is greater than 5, right? So if we were to graph that, here's 5. Everything greater than would not include 5. We'd use an open circle, and then we would shade everything, whoops, I want the highlighter, not the eraser, shade everything this way, okay? So now when I write that in interval notation, you notice the smallest number I would write here is 5. So that's what you see here. And it's not included, so I used a parenthesis. And then it goes all the way up until we get to infinity. And again, because it's an infinity, we use a parenthesis. Okay. And then we have this right here, which is another way of just saying x has to be between 1 and 5. Now, they are saying that 1 is included, and then 5 is not included. So you'll see here, 1 is included. We've got a bracket, 5 not included, so a parenthesis. So this means every number between 1 and 5. 1 included, 5 not included. So this is called interval notation, and sometimes it's a little bit more handy to use than inequalities. But they really are both the same. You could use either one. You'll notice I'm going to use them kind of both today, and I just want you to be familiar with it. You see these in a lot of text sometimes. So, okay, a couple of definitions. We're going to talk about function families and parent functions. So what is a function family? It's really just a set of functions whose equations and graphs have similar form and shape. So like, let's talk about linear function families. So these are all like lines. They might look like this, they might look like this, or They might be horizontal, they might be vertical, but their graphs look very similar, okay? And their equations also look similar. Most of these have an equation like y equals mx plus b. This is like y equals b. A vertical line is x equals some number. So, but generally speaking, they're pretty similar. Okay, so those are called function families. Now, parent functions are where we're talking about the most basic of that kind of function family. Okay, so the simplest version of that. And so for a linear function, that would be like y equals x or 1x. That's the simplest one. It doesn't have a y-intercept, or the y-intercept is 0. So that is the simplest one. So let's just talk about those and take a look at some of the parent functions. But again, a parent function is the most basic one. Okay, so here's the ones we'll talk about in this course. We're going to talk about linear functions. Now you'll notice when we write these, instead of y, we're using function notation in f of x, right? F of x, just another way to say really your output or your y value. But well, you'll often see function notation instead because we'll have different functions and we want to be able to name them quickly, like f of x, g of x, etc. So that's why we're using that. Now, the simplest linear one is f of x is equal to x, and that's just a diagonal line. Okay, so another one is the quadratic function, which is f of x is equal to x squared. And the most basic quadratic function is this parabola that you see here, right? That's the vertex is at 0, 0. You have a couple points like 1, 1, and negative 1, 1. Quadratic function. Okay. We also have a cubic function, so f of x is equal to x to the third power, and this is sort of an interesting shape. It's just like a kind of a squiggle in the middle that goes around the origin. And as you start to modify this function, you'll see maybe more variety like that, or the squiggle in the middle kind of gets a little bit different. But this is the one that you see is the most basic cubic function. Okay, a few other ones that we'll highlight here. The absolute value function, which remember absolute value just makes it all positive. And you'll see these things around that. Everything inside there ends up being positive. Okay, so the absolute value function looks like a V. Again, centered, the vertex is centered at 0, 0. And you can see some of these points here going up like that. Those are important when we try to graph different ones. But that's the absolute value parent function. The square root parent function, a square root of x, this is what that graph looks like. You just have this that's, again, centered at 0, 0. It sort of looks like the top half of a sideways parabola, which is really what it is. And then exponential functions like f of x is equal to 2x. You'll notice this exponential growth. You have here a line. This graph actually never touches the x-axis, even though it looks like it does. It gets really close, but never does. But that's an exponential parent function. So those are kind of the major 6 functions that we'll talk about in this course. And we want to be familiar with these parent functions. Okay. Some things to remember. Domain is your set of all possible x values. Everything in the x. And then the range, if you might recall, is the set of all possible y values. Okay? So let's look at the first part of this, and then we'll talk about the increasing and decreasing. So over here we have a parabola. So I could say this function family then it's the quadratic function family. F of x is equal to x squared. Or you could say function family quadratic. So whatever you want to do, but that's our function family. The domain for this particular graph is every set of possible x values. Remember, x is side to side. So now this parabola just keeps getting wider and wider and wider, and it goes all the way. While it's going down, it also is going this way, and it's also going this way, and it just keeps doing that. So my domain is anything from negative infinity all the way up to positive infinity. Now, we can write from negative infinity to positive infinity, but it's easier to say all real numbers, because everything from negative infinity to positive infinity is all real numbers. And the abbreviation for all real numbers is sort of like this script R that looks sort of like that. So you can feel free to write out all real numbers. You could write from negative infinity to positive infinity, but I like this a little bit better, and it's more typical of what you might see in a textbook. Okay, so that's all my possible x values. How about y values? So y values are up and down, right? So this is basically how high or low does the function go. And in this case, you'll notice the function goes all the way up to here, but does not get any higher. And that right there is, it looks like -2, right? So now since range is y, I'm going to say the range is from y is equal to -2 and down. So we want to say everything less than or equal to -2. And notice I used a y here because that's my range. If it were my x, right, that would be talking about domain. Okay, now increasing and decreasing intervals, this is where sometimes it's easier to use interval notation, but you don't have to. So how do we do this? Well, here's the definition or what we want to look for. Okay. When we identify increasing and decreasing intervals, we always look at the graph all the way from the left over here, right, all the way to the right, and how we're going that way. So starting on the left, the farthest left, all the way to the right. Now, where is this graph? So you kind of think like you're reading or you're riding on this graph. Like this is almost like a roller coaster. You're going to start here and you're going to end over here, right? But this just keeps going forever. So where is this increasing? It starts increasing from negative infinity all the way over to this spot, like all the way over here, way over there, all the way up until here. Now, when we're doing this, we're only looking at the x values. You'll see that's highlighted right here, just the x values, because the increasing and decreasing is already talking about the y values. So we're saying that this increases all the way up until here, right? So that's from, I'm going to do interval notation. That's from negative infinity all the way until, remember x values, all the way until this. And the x value at that spot is 0. Now I'm going to use a parenthesis because at 0, it's not increasing or decreasing. It's actually just holding steady. So that's why we're going to say not including 0. And then where is it decreasing? Well, if we think about the x, it's decreasing from here on, right? Or if we ride this roller coaster kind of down, that's going down. So what is the interval? Well, starting at 0 and then going all the way this way. So that would be at 0 all the way to positive infinity. So that's my increasing and decreasing intervals. And again, you're only thinking about just the x for these two. Okay. It's a little weird at first, but hopefully that will start to make some sense. Okay, so let's try a couple more, and then maybe that will solidify it a bit. All right, so this function here on the left, right here, we notice this is, again, that V shape. So if we come back up here, that looks like absolute value. So I wanna go ahead and say my parent function or my function family would be the absolute value function family, or which you could write absolute value, or f of x equals absolute value of x. Okay. And then the domain, well, the domain, again, from x, this keeps going this way and this way. So the domain goes from negative infinity to positive infinity, or again, all real numbers. Okay, range. The range, once again, that's your y, that's up and down, right? So it looks like it goes all the way up until here, and it's everything down below that. So my range is from y is less than or equal to, again, -2 on this one. Okay. All right. Increasing intervals. This is really similar to what we just did with this one. It's just, right? Because we're from this side, we're going this way. It's from negative infinity all the way up until here, which my x value there is 0. Okay, so right, it's going up that way. And then after that, it's going down, and that's from 0 on to infinity. So this is the exact same interval for increasing and decreasing. Okay, so a little, maybe not that much more challenging than the one we just did. Now let's take a look at another one. Okay, so here you can see that curved line. So let's see how that looks on our function family. This appears to be similar to this one, just turned upside down. So an exponential parent function. So I might say f of x, f of x equals 2 to the x is my function family. Something related to that, I think. My domain, again, this one goes all the way to negative infinity. This keeps going down, but also getting this way. So this is also all real numbers. Okay. My range, so you'll notice it doesn't get any higher than this. This exponential functions curve and they kind of flatline, but they actually are getting close to this straight line, but they actually never reach it. And that's -2. So this would be y is less than -2, not less than or equal to -2. It never actually reaches that spot. Okay. Now let's talk about intervals. Where is this graph increasing? Remember, we read this from left to right, and you can see that everywhere we start on here, it's decreasing. So where is this increasing? It's not increasing ever. It's always going down. So decreasing, where is it decreasing? Well, it's decreasing from negative infinity all the way up until positive infinity, everywhere. So kind of an unusual one there. All right. That is how we talk about parent functions and our introduction to them. So you can go ahead and work on the parent function assignment. I hope this makes sense. See ya.